In the area of science and gigantic mysteries, the subject of what existed previously to the gigantic explosion has blended conversations and intrigued characters for quite a while. This huge question doesn't just test our understanding of the universe, it challenges the very limits of human knowledge. Imagine standing at the edge of existence, looking into the colossal shadow and pondering what lay there before our universe was conceived. The event of the Big Bang marked the beginning of time, space, and all that we know. But was there a moment before this? Could there have been a state of nothingness, a calm before the cosmic gathering began? And if so, what was it? Or perhaps something even more alarming existed before time itself? As we delve deeper into this question, science takes us on a journey beyond the universe's starting point, into ideas that challenge our consciousness. Physicist Brian Cox, known for his exploration of the wonders of the universe, suggests that something surprising might have existed before the enormous detonation. He challenges us to rethink our understanding of reality and existence. In this examination, we'll dissect the science, the speculation, and the fascinating mysteries that might explain what existed before everything. We'll explore concepts such as inflationary expansion, quantum fluctuations, dark energy, and even multiverses. The answers we uncover might astonish you, yet they could also open new understandings of our place in the universe. Get ready to dive deep into a world beyond imagination and science, where the unknown still weaves through the shadows, leaving scientists awestruck and sometimes even unsettled. Let's explore what existed before the Big Bang and why these theories challenge everything we thought we knew. To appreciate what may have existed before the Big Bang, we first need to carefully examine what the Big Bang truly was. Scientists define the Big Bang as the moment when the universe became extremely hot and dense, expanding rapidly to initiate the formation of all matter, energy, and fundamental forces. When we look toward the night sky, we see evidence of this hot beginning, with galaxies spreading outward from an initial singular point. But why did this happen? Furthermore, was there a time before this dense, hot start? According to the theory of cosmic inflation, there was indeed a before, and it was far from empty or peaceful. Cosmic inflation suggests that before the Big Bang, the universe was in a state that was cold, empty, and stretched, essentially like a vast vacuum. However, this vacuum wasn't entirely empty. It contained an enormous amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, happened so quickly that it essentially laid the foundation for everything that followed in a fraction of a second. Space expanded at unimaginable rates until the inflation slowed, and the energy transformed into matter particles and the forces that triggered the Big Bang. But what was the nature of this energy? Why did it suddenly expand the universe? And why did it stop? Scientists believe that this cosmic inflation created pockets of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly with tiny bubbles forming here and there, each bubble representing a universe, including our own. This idea, known as the inflationary multiverse, suggests that there are possibly infinite Big Bangs and an infinite number of universes. Our own is just one of many. This vast, mind-bending reality challenges our understanding of the universe itself and leaves us with an even bigger question. What else is out there? The idea of nothingness before the Big Bang is speculative, at least according to our current understanding. Even if we were to remove all energy, particles, and radiation from the universe, it would still not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that weave an intricate cosmic fabric. Even in its most vacant state, space is never truly empty. If we imagine stripping away all forces, leaving a dead void, the universe would still generate new kinds of energy. This reality alone baffles scientists, as it suggests that true nothingness might be impossible within our infinite comprehension. Space itself has properties, rules, and constants that prevent it from being completely void. Imagine creating a region with absolutely nothing in it. No particles, no radiation, and no energy, except quantum fields and fundamental constants. These would still exist, suggesting that even nothingness has properties. For example, there is a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. In this state, particles can still momentarily appear and disappear, creating an eerie resonance of movement, even in what should be empty space. This challenges our idea of a real void and suggests that, yes, even before the Big Bang, something existed that scientists are only beginning to understand. One of the most astonishing theories in modern cosmology is the possibility of eternal inflation. If inflation could cause our universe to exist, it is possible that it has been happening forever. Brian Cox describes an unimaginably vast inflationary multiverse, where universes are continuously created and expanded. Imagine each Big Bang as a spark igniting a new universe while inflation continues in different regions, creating countless other universes. This cycle, in theory, could go on for eternity. This idea of infinite universes gives rise to a fascinating concept of a fractal-like universe, where each new universe might give rise to its own Big Bang. Every universe exists as a separate, independent domain, unaffected by others due to the rapid expansion of space. For researchers, this hypothesis is both exciting and unsettling, as it suggests an endless multiverse with no definitive beginning or end. Imagine our universe as just one tiny piece of a colossal cosmic web, forever expanding, constantly birthing new universes. And what if the most unsettling truth is that there is no before or after, but rather a timeless pattern of universes forming and decaying? Our understanding of nothingness changes when we consider quantum field theory. According to this theory, the universe is not merely a collection of matter floating in space. It is a complex network of energy fields that fill the cosmos, connecting to create everything we observe. These fields function like invisible oceans, with particles acting as waves or disturbances. Even when these fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can spontaneously appear and vanish, momentarily borrowing energy before returning it. This phenomenon results in virtual particles, substances that briefly exist and then disappear, leaving only a faint trace of their presence. The concept of virtual particles challenges the very idea of a true void. Imagine an empty universe where all matter, radiation, and energy are removed. Would you have absolute nothingness? According to quantum field theory, you wouldn't. Even in a vacuum, fields would remain active, sometimes generating fleeting particles. This constant activity, even in what should be nothing, suggests that the universe does not recognize our concept of emptiness. Fields and forces persist, filling the cosmos with hidden energy that prevents absolute voids from existing. This realization raises an intriguing question. If fields create particles, and particles create matter, could the universe itself have emerged from this nothing filled with quantum fields? Dark energy, a mysterious force currently driving the accelerated expansion of our universe, adds another layer of complexity to this puzzle. Universe, but did dark energy exist before the Big Bang? From certain perspectives, the fact that dark energy exists today is a leftover of an energy field from before our universe's development. The properties of dark energy seem to suggest a colossal hidden force that might have existed in some form prior to the Big Bang. Some theories suggest that dark energy, in a much stronger state, could have controlled the inflationary stage, causing rapid expansion. The presence of dark energy suggests that, regardless of whether our universe were exhausted of all matter and radiation, this force would continue to expand the fabric of spacetime. This thought leads to an upsetting question. If dark energy was present before the Big Bang, could it have formed the circumstances that led to the birth of our universe? Could dark energy be the silent architect of inflation, or even the true beginning of our universe? As we explore this possibility, we face the potential of dark energy not just as a force shaping our universe, but as a key that could unlock the secrets of the multiverse itself. Another theory that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology. The idea that the universe goes through endless cycles of birth, death, and resurrection. In this model, the Big Bang is not a one-time event, but rather part of a timeless rhythm where universes expand, collapse, and then regenerate in another cycle. This theory suggests that our universe might have been reborn from the remnants of a past universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning, but rather an eternal series of universes emerging, growing, and renewing themselves over and over again. Cyclic cosmology raises significant questions about time, as it suggests that time itself might be cyclical rather than linear. If this theory is correct, it could mean that what existed before the Big Bang was just another version of the universe, one that collapsed only to give birth to our current universe. For researchers, this theory offers a rich answer to the question of ultimate origins, proposing that there is no true beginning. The universe has always existed in some form, transcending our ideas of time and existence. Early-stage gravitational waves are another intriguing idea that could hold clues to what existed before the Big Bang. Gravitational waves are ripples in spacetime caused by massive cosmic events, and scientists believe early-stage waves, if ever detected, could reveal insights into the universe's earliest moments. These waves could serve as echoes of what came before the Big Bang. Should they be identified, they might provide proof of the universe's previous states. The potential discovery of early-stage gravitational waves is one of the most exciting possibilities in cosmology today, as it might not only reveal the truth about the Big Bang but also offer a glimpse into the cosmic state before our universe was born. This theory offers a tantalizing prospect, detecting gravitational waves that could act as fingerprints of a pre-Big Bang universe. As we continue to explore what could have existed before the Big Bang, we delve into concepts that push the boundaries of our understanding, challenging even our most fundamental assumptions about spacetime and existence itself. One of the most mind-boggling ideas comes from the realm of quantum gravity, a field that seeks to merge quantum mechanics with general relativity. This merger could potentially reveal a unified theory of everything and might offer insight into what existed before the Big Bang. Quantum gravity suggests that space and time are not smooth, continuous entities as we experience them, but instead are discrete, granular structures. This theory posits that the fabric of spacetime itself could have been formed from a microscopic Planck-scale structure, with tiny quantum fluctuations shaping the universe in ways we cannot yet fully comprehend. In this view, what we perceive as the smooth continuum of space and time might have only emerged from these fluctuating quantum fields. Thus, before the Big Bang could be described by a radically different concept of reality, one where space and time themselves were not fully formed. Another possibility is that the universe is part of a vast cosmic landscape of possible universes, each with different physical laws and constants. This theory, known as the string landscape, arises from string theory, which suggests that all fundamental particles are actually tiny vibrating strings. In this framework, there are many possible configurations of these strings, each corresponding to a different set of physical laws. The string landscape could imply that our universe is just one of many, each emerging from its own distinct Big Bang-like event. The existence of such a landscape also brings forth the notion that other universes might have different dimensions, different strengths of gravity, or even different types of matter. In this view, our universe might not be unique, but rather part of a multiverse, a collection of universes, each evolving independently. The multiverse theory provides a speculative yet fascinating answer to the question of what came before the Big Bang. Another universe, in a different configuration, potentially leading to infinite cycles of creation and destruction with no definitive origin. In addition to these cosmological models, some theoretical physicists have also considered the role of black holes in shaping the nature of the universe. A hypothesis gaining attention is that our universe could be the result of a black hole formed in another universe. In this scenario, the singularity at the center of a black hole could serve as a gateway to another universe, with the Big Bang being the moment when such a black hole gave birth to our cosmos. This hypothesis is supported by the fact that, according to general relativity, the singularity at the center of a black hole is a point where space and time curve infinitely, creating a region where the known laws of physics break down. It's possible that the extreme conditions inside black holes could lead to the creation of new universes, which may suggest that what we consider the Big Bang was just the birth of our universe from the singularity of an ancient black hole. Exploring these concepts requires a deep dive into the very nature of time itself. Some cosmologists speculate that time, as we understand it, may have had no meaning before the Big Bang. If time began with the Big Bang, then there may have been no before in any conventional sense. According to this view, time itself might have emerged from a quantum fluctuation or from a primordial state where the usual distinctions between past, present, and future did not apply. This could lead us to rethink the concept of causality, which relies on the assumption that events happen in a linear sequence. If time did not exist in the way we experience it, then the question of what came before the Big Bang becomes nonsensical, as there would be no temporal framework to support it. Further complicating the picture are theories of cyclic time. As mentioned previously, cyclic cosmology suggests that the universe undergoes endless cycles of birth, evolution, and eventual collapse. In this model, the Big Bang could represent just the most recent bounce in an eternal series of universe cycles. These cycles might not be identical but could evolve in different directions, each with unique physical properties. The cycle of the universe, according to this theory, would be a continual process with no true beginning or end, rendering the question of before the Big Bang meaningless in the conventional sense. The idea that time itself might be cyclical suggests that every Big Bang could be followed by a contraction and another big crunch, with the universe reinitiating itself in an endless loop. Another avenue of investigation into the nature of the cosmos is the potential of a primordial soup of particles and fields that existed before the formation of stars and galaxies. This concept suggests that before the universe began its rapid expansion, it was filled with a dense and hot mixture of elementary particles, including quarks, leptons, and bosons, all in a state of extreme energy. Ultimately, what existed before the Big Bang remains one of the most profound mysteries in science. As our understanding of quantum mechanics, cosmology, and fundamental physics deepens, new theories will continue to emerge, offering increasingly complex and sometimes paradoxical explanations for the origins of our universe. While we may never fully grasp what came before the Big Bang, the pursuit of this knowledge will continue to stretch the limits of human curiosity, driving us to explore the unknown frontiers of existence.